Okay, so continuing on with the Nebular Hypothesis, there are going to be some laws of physics that are going to drive some of the processes that we'll see in forming a solar system. Some you'll be familiar with that we've already covered in this class, some you won't, but I'll explain them as we go. So I have basically 5 things from physics that would need to go into forming a solar system. The first physics is that we need here going on, we've already discussed, is of course gravity. Of course, what we know that gravity does is it pulls mass together. It's always an attractive force, always pulls things together, never pushes them apart. So we'll definitely need gravity in this. The next thing that we've already encountered when discussing the moon is this centrifugal force. I always feel obligated when talking about the centrifugal force to put a little star next to it or something like that, because it's not a real force, but for the purposes of our discussion, though, we're going to just pretend like it is, but it isn't actually a force, and we just don't need to worry about the details at the moment of why it isn't. But there's my star right there for any hardcore critics out there that may be watching. The third law of physics that we need is frictional heating. So frictional heating. What that's about now is something you can do here if you happen to be listening to this, is to basically take your hands and sort of put them together and just rub them together like this. And if you just keep doing that, you see your hands get very, very warm as you do that. You start rubbing them back and forth. You've probably done that before on a cold day outside to warm your hands up. And that's exactly what frictional heating is. In other words, when things start to rub together, like we did, they frequently just sort of get hot. And that's just because the surfaces are dragging across each other over and over and over again. And the surfaces just get a bit hot. And so frictional heating will actually be important, believe it or not, in forming a solar system. And there's 2 more. One is called the conservation of angular momentum, which I'll show you. And the last one then is almost the same. Conservation of energy will also be important for this. And this one you might be a little bit familiar with from a science or physical science class you might have taken before. But it just says that energy is never created or destroyed. It's just transferred from one form to the other. And you might be familiar with that. So this in a nutshell then are the 5 physics laws or concepts or processes that we'll need when we start describing the Nebular Hypothesis starting in the next video. Gravity is going to play a role. The centrifugal force is going to play a role. Heating that you get from friction or things rubbing together is going to play a role. Something called the conservation of angular momentum is going to be important, and the conservation of energy. So with these 5 things, the last videos that told you some of the things that we demand this theory explain, will now allow us, that's sort of our setup for the Nebular Hypothesis. So now in the next video, we'll begin then with illustrating where the solar system came from.